So this is example 5. If you notice, I didn't include the part A, because the part A is a set of ordered pairs. I'm just not interested in dealing with that. Let's jump to the equations. Okay, so letter B, right, g of x is negative 3x squared plus 4x plus 5. Okay, again, think all real numbers, and then take away any x values that lead to a divide by 0 or the even root of a negative number. Is there any dividing by variables? No. Are there any square roots going on? Not squares, square roots. No, there's neither one. All real numbers. Right? Just look for those two situations. See any? Negative is fine. Negative numbers are real numbers. But we're not this squared here is not taking a square root. We mean square roots. That's what would be not acceptable. How about the letter C here? H of x is 1 over x plus 5. Are there any x values here that might lead to a divide by 0? Negative 5, right? If you substitute negative 5, you got 1 over 0. Not allowed. So the domain is all real numbers except negative 5, which you could write it out like that, or you could just say x does not equal negative 5. That assumes that it could be anything else. You don't need to say that part of all real numbers except, but if you do, it's not wrong. Okay. What about the letter D? Does that look familiar at all? From what class did you use things like that? Geometry. Does anybody remember what that's the formula for? Volume of a sphere. It's the volume of a sphere, right? Where V is the volume of the sphere and R is the radius of the sphere. Okay, in this case, do you see any dividing going on? By a variable? No. Do you see any square roots? No. But would it really make sense to have a radius which is 0 or less than 0 for a physical thing, for a sphere? So in the context of the problem, there's no way that you can let the radius be a negative number. It wouldn't make sense. You couldn't also have a radius be 0. What kind of sphere would you have if the radius of the sphere was 0? You wouldn't have a sphere anymore, would you? So you have to say that the domain of this one is R is greater than 0. And that's just because of the context of the problem, not because you're doing any dividing by 0 or square roots of a negative.
Wait, how would it be? How come it would be over?
Because can you let the radius of a sphere be a negative number? Does that make sense? So don't let it. Don't let R be a negative number. Does it make sense for the radius to be nothing? What sphere has a radius of 0? None. Okay. In a formula like this, when the formula has real meaning, then you have to take into account the context of the problem. Okay? Something like here, right? I mean, these are just equations. X doesn't mean anything to us, so we would have to be more careful than that. A formula, there's some meaning that goes along with it. Justice. Okay, well, first you have to set it up, right? 4, we know we don't want to take the square root of a negative, so we set it up. Let's let this expression be greater than or equal to 0. If we solve for the x values that make that true, we will have our domain. So 4 is greater than or equal to 3x. 4/3 is greater than or equal to x.